Welcome to create finite state automata using JFLAP. This is Dr. Teo Kim Heng, Informatics Academy. JFLAP stands for Java Formal Language and Automata Package. It is an interactive visualization and teaching tool for formal languages and automata theory. We can start JFLAP by double-click on the jar file downloaded from jflap.org. The application allows us to play with many experiments, including finite automata, push-down automata, Turing machines, grammar, regular expression, and so on and so forth. This talk is about how to use JFLAP to experiment with finite automata. So you click the first option to launch the application for finite automata. This launch the editor for finite state automata. The toolbar provides 4 buttons, which are Attribute Editor, State Creator, Transition Creator, and Editor Tool. Our first lab exercise is to use JFLAP to design a very simple finite state automaton called M0. M0 will accept all the string over binary alphabet 01, such that the string ends in 0. In other words, the language of the machine is all the string x, that x belongs to sigma star, and x ends with symbol 0. First, we click the State Creator tool and then click on the canvas 2 times to create 2 states. The system automatically gives the name Q0 for the first state and Q1 for the second state. Once we got 2 states created, we can define transition between the state of the automata. We are going to use the transition editor to create 4 transitions. For example, in state Q0, reading symbol 0, it will go to state Q1. And from state Q1, reading 1, it will go back to Q0. In Q0, reading symbol 1, it will stay in Q0. At Q1, reading symbol 0, it will stay at Q1. The purpose of the state Q0 is to recognize that the last symbol scan is not a 0. For example, when you scan a 1, you go to this state. When you scan anytime when you scan a 1, you go to Q0. And Q1 is to remember the last symbol scan is a 0. So from any state, when you see a 0, it will go to Q1. At the very beginning, the machine didn't scan any 0, so it should be at Q0. At any time, when you scan a 0, it should go into Q1. So Q1 should be the final stage. And Q0 should be the initial state. In order to tell the system that Q0 is initial state and Q1 is the final state, we use the Attribute tool. Click Attribute tool and right click on Q0 and select Initial State for Q0. Right click on Q1 and select Final State for Q1. Once we design the automaton, we can test the automaton by feeding it with input. We can test the automaton step by step, fast testing. Here, I will explain the multiple run test methods. You click input and choose multiple runs. The system will provide a window for us to enter the test data, multiple test data. Once we enter the test data, we click Run Inputs, and the system will feed the data to the automaton one at a time and see whether the automaton go into final state or not. If you go to final state, you will accept the string, otherwise you will reject the string. So the result is quite successful. For example, the first string does not end with 0, so the system reject it. The second string and third string end with 0, so the system accept it. The last string does not end with 0, the system reject it. In the second exercise, we are going to use the same tool to design a slightly more complex finite state automaton called M001. The purpose of this machine is to recognize all the string over the binary alphabet such that it contains the substring 001. In other words, the language of the machine are the string in Sigma star such that the string can be decomposed into Y001Z. Okay. In other words, 001 is a substring of X. In order to do so, we can use 4 different stages to remember what are the prefix of 001 that we have scanned so far. The prefix of 001 can be empty string, can be 0, can be 00, can be 001. So, when the machine scans a substring 001, it will go to this state, and Q001 will be the final state. At the very beginning, the machine didn't see any symbol at all, so it should be in state Q. This is the finite state automaton that recognize the substring 001. At the very beginning, the machine didn't see any part of 001s, so it stay in Q. One is see a 0, it go to Q0. One is see another 0, it go to Q00. One is see a 1, it go to 1. After that, this is the final state. No matter what 0 and 1 you recognize, because the machine had already seen 001. Now, we look at other situation. For example, instead Q0, that means what? It just recognize a 0. But the next symbol is 1, then essentially there's no substring of 001 recognized. Instead Q00, that means what? The machine has already seen 2 0. When it see another 0, it remains in the same state because the last 2 symbols that the machine scan is still 00. You should pause this video and convince yourself that this automaton really recognize a substring 001. This is the end of this tutorial. Thank you for your participation.